All right, good evening, ladies and gentlemen. Thanks for attending. This class is going to be on map reading and land navigation. A little background and purpose. The purpose of this training module is to inform the learner how to read a topographic map, use the information provided in the map legend, plot your own location as well as your intended destination accurately on the map, to plot your route, determine distance and direction between points. Why would you want to know this? Well, millions of people spend their recreational time in the outdoors, hiking, bike riding, canoeing, etc. Many of those people only have a very basic understanding of map reading. Most do not know much about determining one's location or planning a route to a destination across the park or down a river, etc. For the person who has a more advanced understanding of the concept, they'll be much more confident while enjoying the outdoors. If you were ever to lose your way, that you would have the skills needed to reorient yourself with the surroundings and continue on to your intended destination with some confidence of being able to get where you intended to go. The objectives of the training are, given a topographic map, the student will become familiar with the map and its features. The student will be able to correctly identify the scale of the map using the information found in the map legend's area at the bottom. Given the same topographic map, you will be able to correctly identify the GM angle of the area depicted by the map. In this area, it's -3 degrees. That's shown towards the right edge of the map legend. It looks like two arrows. You're also given a map protractor, a utensil to write with, and we'll be talking about different grid coordinates throughout the training. We're going to discuss how to plot 8-digit grid coordinates of a known location, or given a known location such as a restaurant or something like that, you'll be able to determine the 8-digit grid coordinates of that as well. You'll be able to determine route lines in between points, and then using the map protractor and a pencil, you'll be able to determine the distance and direction between points. So if you were going to walk from here to a different point, you'll be able to tell which direction you need to head out in using your compass to get there, and you'll be able to convert your map azimuth, which is the azimuth you plot on the map, to the magnetic azimuth, which is what you would set your compass to, and that's what you use the GM angle at the bottom of the map for. And then the last thing you'll be able to do is we're going to use the compass and your map, and I'm going to show you how to orient yourself to your 360 surroundings in the real world. And we'll explain that when we get there. Right? Alright, so does anybody know anything about map reading already? Anybody ever used a topographic map, used a compass to try to get around the park or anything like that?
No.
No.
Street map.
Had a good sense of direction.
Yeah, street map.
Like a real map.
A good sense of direction is a good place to start. For reference, would you mind pointing out to the rest of us who may not be familiar which way is north, for instance?
Do you want me to catch one for you, sir?
Map reading and land navigation is a valuable skill that anybody who enjoys the outdoors, various types of outdoor recreational activities can benefit from. There are different types of maps available, but for land navigation, a topographic map is the map of the best choice. This is another example of a topographic map. It's probably a better example than the one that you guys have. However, for training purposes, I felt it was better to use the area that you were familiar with. That's a topographic map of Governor Dodge State Park up in Wisconsin. This is a map of Rock Cut State Park. The reason this type of map is used is that the information is not available on other types of maps and is more detailed, allowing you to make better use of it. Some of the information that a topographic map provides is a grid to use to plot coordinate points used for navigation by plotting your points on the map and then determining your distance and direction between points. The topographic maps also provide some elevation detail. They have contour lines on them, which if you look at the map of Governor Dodge, you see lines and zigzag all over the map. If you follow a line around the map, that is at a consistent elevation, and the lines kind of run parallel to each other more or less. And the darker ones, if you follow them long enough, you'll see a number on there. That's elevation in feet. The maps have the dark or major contour lines at specified intervals, depending on how much the elevation changes in a given area. The difference in elevation between the lines may be greater or less. For instance, the maps of this area we're using, the elevation doesn't change very much, and so the contour lines are only 10 feet between each one. On the other map, I think it's 40 feet between each line.
Only 800 feet of sea level.
The elevation differences between contour lines varies with the scale of the map. Larger scale maps, a map of 1 to 100,000 or 1 to 250,000 might have 40-foot contour intervals, such as that. One smaller scale maps, 1 to 25,000, 1 to 50,000, may have 10 or 20-foot contour intervals. For example, if the major contour lines are 100 feet in elevation apart, each minor contour line represents a 20-foot elevation difference, and you can get even more precise by recognizing that halfway between two contour lines would represent a 10-foot elevation difference in that preceding example. The contour lines offer an accurate two-dimensional representation of our three-dimensional world. The contour lines in the topographic map give us a top-down view of the terrain we are in. We can take the information offered by the contour lines on our topographic map and compare that to what we see in front of us when we're out in nature. Around this area, there's not much terrain relief, but if you were at Governor Dodge, for instance, and you were walking around on the trails and you lose your position, you can actually look around in front of you and pick out a couple of recognizable points in the park and then locate them on the map and use that to determine fairly accurately where you're actually at on the map. Some things to look for. The contour lines will also show you locations of hills or hilltop. A hilltop on the map will look like a complete circle, where there may be concentric circles. A ridge would appear as a series of hilltops, so you might have 2 or 3 sets of circles in a row. That would be a ridge. Canyons might appear as a canyon would appear in a topographic map as being contour lines that more or less run parallel to each other, and then having increasing elevation on both sides. And their contour lines are going to be fairly close together, rather than rather than spread apart. And oftentimes there's water at the bottom, water being shown in blue on the colored map, and a different shade of gray on the other ones. Once you've established your location on the map, you can plot your points or points that you intend to travel to on your map using the map protractor. That's the plastic tool I've provided for all of you. Map protractors can typically be used as maps of all the most commonly used scales: 1 to 24,000, 1 to 25,000, 1 to 50,000, 1 to 100,000, and the one that's used for 1 to 25,000 is also used for 1 to 250,000, and recognizing the factor of 10. For our training, we're using the map that's 1 to 24,000. So we'll be using that section of the protractor that is scaled appropriately for our maps. Can everybody find the section of the protractor that's,
You lost me on the protractor. Is it the middle section?
yeah, it says right there, 1 to 24,000.
It's
So
that one,
it's
yeah.
this
Gotcha.
little box right here, it's defined between here and here.
Oh.
Alright.
Here?
There.
Look at it. Where the 1,000 is?
Yeah.
So the 1,000 there, so
Oh,
1,000 to
okay.
1,000.
Can you see that?
On the,
Amy does it.
No.
the map is, the boxes on the map are set out 1 kilometer apart, or with a kilometer is 1,000 meters. And the section of the protractor that we're using is scaled for that, so it'll help
each
you
box is
determine
that size.
the distance in between each one of the grid port, or each one of the major grid lines on there. And then we'll be able to determine down to within 10 meters the location of our intended target, utilizing the protractor in conjunction with the grid lines that are on the map.
And each mark is 10 meters?
Each major mark is 10 meters, and each of the small tick marks is 2. I take that back. Each one of the major marks is 100. Each major mark on the protractor is 100, and each one of the small ones would be 20. Grid coordinates are given in even numbered set of numbers. If you divide the set of numbers in the middle, the first half of the set represents the x coordinate, or east-west on the map. Then the second half of the set represents the y coordinate, or the north-south on the map. As an example, to take Boylan High School, for instance, the 8-digit grid coordinate for the center of the main building at Boylan is 28308742. And sometimes, to make it less confusing, sometimes people like to draw a line down the middle to keep the 2 halves separated. So the first 4 are your x coordinates, and the second set of 4 are your y coordinates. If you go back to middle school, you remember that x is your horizontal axis, and your y is your vertical axis. And if you remember geometry, you always go over and then up. Alright, so that's important as we move ahead.
Freaking lost on how you got 28, 30.
Oh, we're gonna go over that.
I got 500, 150.
I'm gonna show you that. So if you lay the 1 to 24,000
Gotcha.
section of the protractor on the map and move it around, you'll notice that it aligns with the grid lines on the map. Your grid lines on here are these dark black lines that have the numbers at the top of them. Those are your grid lines, right?
Okay, I got it.
Each grid square on the map is 1,000 meters by 1,000 meters, so we know that each major tick mark on the scale is slightly taller. You know that with the number 1 through 10 represents a 10-meter acre, and that's why I stand correct, what I said before. And each minor tick mark represents a 2-meter increment. We then align the protractor up with the appropriate grid square on our map in preparation for plotting the point. If, for example, we're going to plot 28308742, we would begin by sliding the protractor so that it aligns with the grid square defined by the north-south grid lines 28 and 29, and the east-west grid lines 3 8, 7, and 8, 8. That right there is in essence a 4-digit grid, or only accurate to within 100 meters. If you're at open terrain, that's probably going to get you close enough to see where you're trying to go. If you're trying to find a building in an open field and you get a 4-digit grid, you'll be able to find it because you can see it from a ways away. If you're trying to find a post in the middle of a forest, you're not going to find it with a 4-digit grid. The only accurate, so that's only accurate to within 100 meters. To continue to get to our 8-digit grid coordinate, we next sight along the x-axis of the scale on our protractor 230. So what you're doing is you lined up your protractor here to begin with. Our target's inside the box defined by 28 and 29 and 87 and 88. So we start with our point of origin right here, and we go horizontally to begin with, so that we slide our protractor along until we get our vertical edge lined up with the point, and then we slide up, and that's how we end up with our point, or with our grid coordinates. So we have 2830 and 8742.
Okay.
Does everybody see that?
I see it now.
I missed the first
No, that's fine.
No,
We're all learning. So the building that we're trying to plot the coordinates of is within inside the box. It's defined by 28 and 29 and 87 and 88, right? So we're going to start by putting our protractor. You see how it makes a bracket, right?
Yeah.
I thought that was between 87 and
Isn't that right?
86.
Okay. So what do you do?
You're using this. You're
Right.
using this one.
You get a
all right?
certain square,
Okay.
just kitty corner to that square.
Remember, you're using the small bracket that has the 1 to
Bring it
24,000
up
in
to
it.
this one, yeah.
your building, and you bring it over to your building. Now your point is in the middle of your building. So, not my point, this is my point, you know my
Did
point.
you see it now?
So
So
now
we
you-
start here with
You're
our point of
in
origin,
You're in
right here at the
3.
corner of our box,
So you got
and then we
28,
go
30. That's how you figure that.
horizontally to begin with. So we slide our protractor over until this edge lines up with our point, which is right here, and then we're gonna slide up
So,
until
this
we
is the
get,
box now.
until our
Okay. Oh,
That's
okay.
the point.
lines up with
All
our
right.
point
So
on
it's
the
like an
map, our
arrow
target,
almost.
and then we're gonna read this up. So this is 2, 3, 4, or 40, and then 42, 44. That should actually be 44, not 42.
You're making an arrow with the protractor.
I had that off a little bit.
Where is
Of
this?
course, my makeshift paper protractor isn't 100% accurate either, but it's close. So
Well, even if you're,
Am I
like you
going
said,
30
building,
that
even
way?
if you're only off
Yeah.
by this much, you're.
Did I do that right?
No, because you're using
No.
you're using the right box. So the center of the building is your point. That's this is your point. That's the center of your building. So you got your 30. So 28,
You'd have to
30.
delete them.
And you got 42 or 44, it's hard to see the line.
So I got it right.
87, 44, 42.
Okay.
So you bring
So-
this across, so this number and this number go together, this number.
So this is my point.
Is
It's right
Correct.
there.
It's like an
All
arrow
right.
to where you
Mhm.
wanna go, so you're making this grid.
Yeah.
And you're reading this spot to this spot. Makes-
Okay. Makes for that.
Okay.
and that's something that I missed pointing out, I guess, is that you're reading to the right. Your first 2 digits of your coordinate are going to be the numbers that are to the left of wherever your building is. Does that make
Yeah.
sense? So you're going
Below the 88
to-
and above the 28.
starting
Okay.
from the left and moving to the right. It makes sense.
Mhm. And better.
if our target was over here, the first two digits of our coordinate would be 29, for instance. And let's say our target was in this box. The first two digits of our grid coordinates would be 29, and then the fifth and sixth digits would be what? 86. Good job. All right, so that's how you find an object when you're given an 8-digit grid coordinate. Another thing that you might want to do is try to determine the grid coordinate of a known object. So let's say we know that we want to go to.
Jennifer's house is not that.
No, it isn't.
It's too far.
That's not it right there?
No.
You gotta go way north of Lakeland.
Oh, you're right, sorry.
You're looking at Elmwood.
I keep thinking all about it.
Yeah.
Well, that's a milestone right there.
I'll take Elmwood. I used to always go to that.
So we're boiling.
So let's say we have a known grid coordinate and we want to make a mark on our map to identify where on the map that grid coordinate is. And we would do this if we were trying to plot a route. And you're plotting multiple points on the map, and then later on we're going to do this. You're going to do it. I'm going to walk you through it. We're going to plot a route in between 2 or 3 points, and then we're going to use that to determine directions in between points. Right? So if we take our protractor, and we know based on our numbers that our target is going to be, because it starts with the 29, it's going to be to the right of our grid line defined with the 29, and then we know it's going to be above the grid line number 86. So we know that our target is going to be somewhere in this grid, all right? So we put the corner of our protractor here at the lower left corner of that grid square, and then we're going to slide to the right until we get our 5 lined up with our vertical line,
Oh.
right?
I can tell you what that spot is.
All right, so now we've got our protractor lined up at 2950 for our horizontal coordinate, right? And then we're going to go up to 8675 for our vertical coordinate, right? So then we're going to slide the protractor up until we arrive at 75 along the edge.
3/4 of the way up to 87.
Something like that. So it's going to be right in that area. And when you're doing this, you want to make sure that you keep your protractor lined up square with the grid lines. If you twist it at all, it's going to throw off your measurements. Right? So it's important that you keep it as straight up and down as possible. So then we just make our mark here at the corner of our protractor. Now on yours, you'll notice that your 1 to 24,000 doesn't line up with the edges of the protractor. What you can do is you can hold your pencil over the corner or over where you intend to draw your point, and then slide the protractor down and then make your mark. Being careful to try to hold your pencil in place when you slide the protractor out of the way.
Because this is 75 up to 87. So that's 8675. And then the
On the right lines?
the 2830,
Let me see what I got one more time.
oh wait, 2830.
Martin Park.
Yeah, it's Martin Park.
Yeah, it's over here.
It's actually just something that I made up that if you found it on
It
the
is,
map.
it's Martin
I
Park.
literally just wrote
Because
down.
there's
You go
29.
halfway between 30.
Yeah.
Between 29 and 30, so that's there.
This
this is where approximately is. I can't do this backwards. That's where I ended up.
Okay.
So that,
I'm
that
thinking seven
grid
and a
coordinate
half
is
here.
in Martin Park across the river.
Mm-hmm.
I'm figuring
Well,
Martin Memorial
This is
Park.
75 right here,
It's
Which
about where
means
the
it's
playground
there.
is.
and then,
So this is a
I'm
kilometer.
right
I
there.
guess if you think about it, a kilometer is 6/10 of a mile, and this would be about a kilometer and a quarter, so probably roughly a mile, like, you know. And then,
You hit 2 miles if you go
Roughly.
from here to that mobile station, so that makes sense.
makes sense. Good job.
This isn't on camera.
All right, so in a, in a real world situation, let's say you were using this colored map of the state park and you had a compass, you had your protractor, the pencil, and you wanted to go see 2 or 3 different points around the park, you're gonna plot points for all the different sites that you wanna see, and you're gonna draw the dots on the map, for each one of those points, and then we're going to use the protractor in a little slightly different manner to determine the directions from one point to another. And if you look at the protractor, you see here you have I guess a target, and then it's it's a 360-degree circle, and it has directions on here. This is actually the north that way, so you are going to be turning it while we're doing this part away. North being 0, south being 180, east being 90, so on and so forth. And what you would do is you're gonna, in order to determine the direction from, like, let's say this point to this point, you would take your protractor and line it up here. You draw a line in between the 2 points. It'll help later on. You don't have to have it, but it does help. And what you do is you place the target over your first point. Let's say this is where we're starting from, and we want to know what we have to set our compass at to get to this point. And so keep making sure that our protractor is lined up with our grid lines. We're going to follow the line out here to the edge, and we can see that it crosses the ring at roughly 42 degrees. All right. That would be what is called,
I was just giving you an example.
that would be what is called a grid azimuth. And in order to get outside in the outdoors and be able to get from one point to the other, you have to know what the magnetic azimuth is. If we go back to our map legend, we learned at the beginning that we need to know what our GM angle is, or our grid to magnetic angle is, and in this area it's -3 degrees. So this is our grid azimuth. On your map it just says N and MN being magnetic north, and N is actually going to be equivalent to your grid north or whatever. So to get from grid to magnetic, you're going to subtract 3. So our grid azimuth is, azimuth was 42, and we want our magnetic azimuth, so we have to subtract 3 from 42, which leaves our magnetic azimuth at 39. All right, so then we go out into the field.
360, you're looking at 310,
Oh, okay, that's what I thought.
310 degrees. Yep. See? back there. If you're in trouble. Yeah, Sarah, you should keep this after the class, you could roast stink bugs with it in the summer. Yeah, I used to.
So we take our compass, and it has a rotating ring around it, and it has a triangle here at the top, and then of course this is your needle. It only works when you hold it flat, but you can't see it, so you rotate the ring. So our target direction is going to be 39 degrees. What we're going to do is we're going to rotate our ring until the 39 lines up with our triangle on there. And then when you're walking, you keep the needle of your compass pointed at the end, but you're walking this way. This points the direction that you're walking, which is going to be 39 degrees. Does that make sense? You can pass that around, you can see what I mean. It's going to show you the right way to walk as long as you keep the needle pointed at the end on there and you head in the direction of the arrows that are depicted on the compass.
Hey Siri, where's the compass? So you follow the red, open compass
Yeah.
is what you follow. Open compass. See?
What?
If you have an apple, you have a compass.
Okay, I'm heading that way.
On maps that are kind of crowded, like on this one, you might have a hard time being able to write your notes on the actual map itself. It may be better to just keep a list along the edge, like, from 1 to 2, 39 degrees, from 2 to 3, 95, something like that. And that way you don't clutter your map. You'll be drawing your dots and your route lines on the map, but you'll probably want to write your notes out to the edge, otherwise you're not going to be able to see much once you get a lot of stuff on there. After determining the azimuth and converting it, then we need to determine the distance between the 2 points. We do this by utilizing the scale provided on the protractor. Again, we already know that our map is only 24,000. We've already talked about how each edge of that scale represents a kilometer. And, so we can use that same section of the map to determine the distance between points. If it's more than a kilometer, you're going to have to skip, make a mark and then keep counting ahead. In this example, our points are less than a kilometer apart, so we can put our corner of our protractor here at one point, and then we can read down the edge and see that our 2 points are basically 56 or 500. It'll be 560 meters apart. All right. Does it make sense? If our points were farther apart, let's say the one was all the way down here, well, you can see that's longer than a kilometer. So the way you would determine that would be you would have to measure from here to the end of your protractor, make a little mark, and then count ahead the rest of the way. So in this example, to here, from here to here would be 1,000 meters to 1 kilometer, and then from here down to the next mark would be an additional 400. Make sense? Sometimes you might have to do that 2 or 3 times or more, depending on the scale. In a big park like that, it may be several kilometers in between points. We talked about the GM angle. I'll give you a little bit of information on why that's important. some of you may know, some of you may not, there is a difference between magnetic north and true north. True north represents the north-south axes of the Earth. Everybody knows from science class that the Earth actually tilts on, it rotates on the tilted axes, and the point at the top of the Earth would represent true north, and magnetic north is actually a ring that goes around the Earth, you know, up there toward the top, but it's a little bit down from the crown. And it's the same thing in the South Pole. There's also a magnetic South Pole, and it's different than the true South Pole. And depending on where at on the Earth you are, the magnetic field lines of the Earth don't run parallel to each other or parallel to the grid lines. There's a variance depending on how far above the equator you are. In this area, it's represented by -3 degrees. Depending on your elevation above the equator, it may be 12 degrees positive. It could be -7 degrees. It just depends on where you're at. And it does change from year to year. This one, it just says -3 degrees. On some maps, it'll say an annual declination or whatever. It does change from year to year. When trying to get around a park or something like that, if the GM angle is only 1 degree, you can probably ignore it unless you're walking 10 kilometers in between points. You're probably still going to be able to find your point. If you're trying to walk from a parking lot to a chalet that's 3 kilometers away, you'd probably be able to find it if you're only off by a degree. If the GM angle is 12 degrees, you probably need to calculate that in order to have a good chance of getting to where you're going. So now that we have our route plan, we haven't actually done it yet, but for our purposes right now, having done this part of the training, the next step would be, before going out in the park or whatever and trying to get from one point to another, before you start walking out your route, one of the things that you need to do is to orient yourself in your map. So we've already set a compass, and the way you orient yourself in your map is, when you're looking at your map, let's say north is that way, you don't want north on your map facing to the east. You want north on your map facing north in the 360 world. You can use your compass to do this. So let's say we don't know where north is, where we're at right now, but we can use our compass to figure it out. And we do that by, it's actually missing this, so because of the metal that's under it. So what we're doing is we're going to rotate our map until north on the map lines up with the north on the compass, like so. So then we know when we're outside, we've got a map in one hand, a compass in the other. This is the way we want to hold the map, not like this. We hold the map upside down or sideways, and we're trying to figure out, where am I at? You've been walking, and you need to try to gain your bearings again. It's important to have your map facing the direction that you're facing. If you're facing east, you want east on the map to be east in front of you. Does everybody understand that? If you have any questions over there? If anybody has any desire to learn more about this after we get done, there are quite a few YouTube videos you can watch and learn how to do this. I've received a lot of military training, and some of you might have participated in Scouts. I found the YouTube videos beneficial. REI, the outdoor store, they also offer training sessions, and they take people off parks and help you be able to get more confident using the map and compass, and have some degree of confidence that you wouldn't get lost if you ventured out on your own.
100 people.
All right, so utilizing what we've learned so far, I'm gonna give you a set of coordinates, and then I want you to tell me what is located at them, or write it down in the, I want you to write it down in the edge, all right? Don't call it out, write it down in the edge, and we'll see if everybody writes the same thing, all right? So you're, I'm gonna give you the coordinates, write the coordinates down on the edge, and then you're gonna find the coordinates on the map, and then you're gonna tell me what's located there, okay?
Okay.
So your 8-digit grid coordinate is 26808830. Good job.
Got a compass.